Now let us see the compounds of nitrogen. The first one is the ammonia NH3. We know it's a very important commercial compound, very commonly used in the lab as well as industrially. It is prepared industrially by a process called Haber's process, in which gaseous nitrogen is mixed with gaseous hydrogen under a very high pressure of about 200 atm and around a temperature of 700 Kelvin, where these two combines to form ammonia. Earlier we used to use iron as a catalyst along with molybdenum as promoter, but nowadays what we do is we use this iron oxide as the catalyst along with small amount of potassium oxide and aluminium oxide as the promoters. The ammonia formed basically is a gaseous compound. So by very easily pressurizing these two gases we can prepare by this Haber's process ammonia. In lab it can be obtained by following ways. It can be obtained from urea, like we know urea is NH2C double bond O NH2. Urea when treated with water, it forms ammonium carbonate, which on its own decomposes to give nitrogen, water and CO2. So this is how nitrogen can be obtained. We can also obtain ammonia, this was from ammonium carbonate. It's not nitrogen, it is ammonia plus CO2 plus water which is formed. Now, ammonia can also be obtained by reacting any ammonium salt, like suppose we are using ammonium chloride, with strong alkalis, NaOH or any other one. So when any ammonium salt is reacted with any of the strong alkalis, what we get is, like in this case, when ammonium chloride is reacted with NaOH, we get NaCl, ammonia and water. In a very similar way, when any of the ammonium salt, like we can have ammonium sulfate reacted with calcium hydroxide, we get calcium sulfate, ammonia and water. So these are its usual preparation methods in the lab, and industry is prepared by Haber's process. Now let us discuss its properties. Ammonia is a colorless, pungent smelling gas which is having boiling point of around 240 Kelvin. It's actually 239.5, so we regard it as 240 Kelvin. So at 0 degrees Celsius or at room temperature, this ammonia is basically gaseous. But remember, it is highly soluble in water, and it makes water, it converts water, it makes water basic by the release of OH minus ions. So its aqueous solution, which is also called liquor ammonia, is a base, is basic in nature. Then let's see the further properties. It is having a very strong complexing tendency. It's a very good ligand because it's a good Lewis base. So it very readily forms complexes with the salts, like if we are having AgCl salt in solution and we treat this ammonium ions, or we are treating like ammonium plus OH minus, like in this way, what we find is very easily it forms complexes like this one. So it has a very strong complexing tendency very easily it forms complexes. This is taken in the form of a liquor ammonia. Similarly, if we treat this with copper sulfate solution, it very readily forms, like if we are having suppose copper sulfate solution, both are in aqueous state, and we are treating it with this liquor ammonia which is present like this, what we find is it forms a complex like this one with copper ions. Now it has also a very since its aqueous solution is basically is having a lot of OH minus ions, we uses its aqueous solution ammonium hydroxide to precipitate number of metal ions. Like in salt analysis in group 3, it is used as a group reagent to precipitate out ferric and chromium and the aluminium ions. We know if we are having aluminium ion and we treat this with ammonia and hydroxyl ion, we know what this aluminium gets precipitated out as its hydroxide. So this is what we get what gelatinous white precipitates of aluminium hydroxide. It's during the group 3 salt analysis. In a very similar way, when ferric ions are treated with this ammonium hydroxide solution, what we get is rust colored ferric hydroxide precipitates. So that is how it has a very strong, it forms precipitates with these metal ions, and therefore it is used in salt analysis as the lab reagent. It is having complexity tendency, it's a very good Lewis base, so it forms complexes with metal ions. I have taken the example of silver chloride and the copper, and as well as its aqueous solution is a very good base which is highly soluble in water.